So this is another tutorial question, 2018, the same tutorial sheet. So this one is saying, find so let's find the zeros of the following polynomial functions. So hence sketch its graph. So indicating the x So that's the question that you're going to do. So you have you have that P of x is equal to x to the power 3 minus 2x minus 7x plus 12. Then B, we have that P of x is equal to 15 plus 5x minus 3x squared minus x to the power 3. Okay, so what we are going to do here, I'm going to do one, then I'll leave one for you to do. So which one should we do, A or B?
B.
B.
Okay.
On A there, I think you've forgotten to add the two squared. It's not squared.
Oh yeah, squared that. Okay, so find the zeros of the following polynomial functions and sketch its graph indicating the x and y intercepts. So remember what we were doing with quadratic functions when sketching their graphs. One, you have to indicate the y-intercept, the x-intercept. What else? Well, for quadratic functions, we used to also indicate the turning points. But today, since we haven't done any calculus, so we are not going to indicate the turning points. So we just want to give a picture of how the graph of this function is. So the first thing is first, you're going to find the x and y intercepts. So how do you find the x-intercepts? So the x-intercept, y is 0. So you are going to equate this equation, your equation, to 0, and then find the zeros of the polynomial. So for the y-intercepts, in the y-axis, x is 0, so you find p of 0. So let's start with the x-intercepts. So the x-intercepts, so we said in the x-axis, y is 0, so you equate p of x to 0, which simply means you equate 15 plus 5x minus 3x squared minus x to the power 3 to 0. But this one, guys, you can rearrange this one and get x to the power 3 minus x to the power 3 minus 3x squared plus 5x plus 15. This will give you a 0. Then what else do we need to do here? Okay, so we can do this here. So we need to find the factor, at least one factor of this polynomial function here. And then you can find those factors by looking at the coefficient of the x value with the highest power, the x with the highest power, which is -1 here, and looking at a naught. So you are going to look at, consider first a naught, which is equal to this 15, then an, which is the degree of the function there, which is -1. So the possible factors of this polynomial here lie here. So we are going to have factors of this one here, which is 1, we have 3, we have 5, and 15. So this should be plus or minus, plus or minus, plus or minus, plus or minus 1. So the possible factors are these. Yes?
Where has the -1 come from?
The -1, it has come here. This coefficient here.
Oh, okay, thank you.
Yes. So I said we are looking for the possible factors of this polynomial function. And the possible factors, we consider the constant term here and the coefficient of the highest power in this polynomial here. So this is what you are going to do. So you use the try and error method. I'm sure you know of it. So the possible factors would be this, because -1 is here already and 15 is here. So we have that also 15 over -1 is also a possible factor, but this is equal to -15, which is already there. So I want to make mention that we are going to revisit this. I'm sure you know that. So we are going to start. I don't know which one. Let's start with +1 here. So you try, okay, that's P of 1, which you're going to have. So it's -1 to the power 3 minus 3, then 1 squared plus 5. Then you have 1. Then you have that is plus 15 there. So we are going to have, this one is -1, this one is -3, this one is plus 5, and this one is plus 15, which is equal to this one plus this one. You get -4, 2. You get 16, not equal to 0. That is not equal to 0. You go on. I'm sure. So if you're -1 here, I'm sure it can't work. So let's try 3. So you try P of 3, which will give us -3 to the power 3 minus 3 squared plus 5 by 3 plus, this is 15. So this is going to give us, this is -27. It's also -27 plus 15.
Sir, my connection died there a bit. Can you please just go back a few steps?
Huh?
My connection died a bit. Can you please go back a few steps?
We go back?
Yes.
Okay. So you're saying we are looking for a factor of this polynomial function here. This one here. So here we said we consider the constant term and this coefficient of the highest power there, -1. So those are the possible factors, and the possible factors you find are factors of 15 here. 15. and the factors of -1. But these factors should be plus or minus, plus or minus, plus or minus. So we try all of them. Are we together? So this is what we are doing. And then you find P of 1 we've tried, P of 3 we've tried. So you're trying P of positive 3 here. This is equal to this one. What do you get? That is minus 54 then plus 80. We're going to get what? 4. We're going to get minus 24. Wow. Okay, that is not equal to 0 as well. It's not a factor. Let's find P of minus 3. Try this one. This one is equal to minus 3 to the power 3 minus 3 minus 3 to the power 2 plus 5 times minus 3 plus 15, guys. This is equal to minus, this is minus positive 27. This one squared will be minus 27. This one times this one will be minus 15 plus the 15 there. So you're going to see that this is 0. 0, 0, we're going to get a 0. Therefore, since P of -3 gives us a 0, then we are going to have that. Therefore, x plus 3 is a factor of P of x. Question? Any question? Since x plus 3 is a factor, to find the other factors, we are looking for the zeros of the x-intercept. So x plus 3 is one factor. So we are going to use x plus 3 and divide it into the polynomial given. So we have that. Okay, let's use long division here. So you have x plus 3. So you have data functions. You have minus x to the power 3 minus 3x squared plus 5 plus 15. So x is there to give you minus x squared. So we're going to have minus x to the power 3 minus what? 3x squared. Subtract there. What do we get? Get a 0 here. You also get a 0 here. So you have plus 5x there plus 15. X there to give you plus 5. This one times that one, you get 5x plus 15. Subtract there, get a 0. Are we together there? Therefore, so P of x, you can write P of x as x is equal to this one, 3 times 5. Now this, remember that one is equal to 0. How do we factorize this one? What comes into your mind there? You have a difference of 2 squares, not so? So let's continue from here. Guys, this is going to be x plus 3 times, how can you factorize this one? That's okay. This is the difference of 2 squares. We can factorize. We have that x plus 3 equal to 0. And this one here, root of 5 minus x equal to 0. And this one here, root of 5 plus x equal to 0. So here we have that x is equal to minus 3. Here we have that x is equal to minus, not minus, but the root of 5. And here x is equal to minus the root of 5. So these are the x-intercepts. Those are your x-intercepts. And then for the y-intercepts now, very easy. Y-intercept, in fact, is just intercept. So in this y-axis, x is equal to 0. So you simply find p of 0, which will give you, where's the function? Where's the function? Okay, it's there. Which is going to give you 0 to the power 3 minus 3 squared 5 plus 15. So this is going to give you 15. Okay, so that is enough information now for you to sketch the graph of this polynomial function. So you have the x-intercepts and the y-intercept, which we just found here.
Excuse me, sir.
Yes.
Can you please re-explain on how you found the y-intercept?
Okay, so the y-intercept, I'm saying the y-intercept in the y-axis. So we are looking at for the value of, where the polynomial function here, the graph of this polynomial function cuts the y-axis. And in the y-axis, we know that x is 0. Are we together? X
Yes.
is 0. Yes. So you just find p of 0 using that function. And then you are going, observe this. So there's x, x. So this is just a 0. Then you get 15 there.
Okay, thank you.
So that is the y-intercept. Now, we now can sketch the graph of this polynomial function. So you have x, you have y there. Okay. So you have that the x-intercept, one of the x-intercepts is -5 and -3. So you have that. And then we have that the y-intercept is somewhere here. Okay, so let's just say, so guys, this graph will look like something like this. Okay, so it will go maybe somewhere like that. Then it will come like that. So that's what we are going to have. So just indicate. So the x-intercept, which one is the positive value, guys? So it's logic here, use logic. So x is equal to 5, the root of 5. So there, that is the root of 5. Then here, which one is bigger between -root of 5 and -3? -root of 5 is bigger and -3 there. So that is what you have. You also indicate the x-intercept, which is 15. So that's how it's going to look. So that's how you get full marks. So sometimes, okay, the graph cannot be perfect, but just please indicate where the graph cuts the y-axis and the x-axis. That's what they need. So where the graph, so indicate the x-intercepts and the y-axis. So you can even say p of x here is equal to that function there. So minus x to the power 3 minus 3x squared plus 5x plus 15. So that is how the graph is going to look like. So yeah, I don't want to mention this where you consider. So you are going to observe when you do the other other example. You are going to observe the graph will be, yeah, might be a bit different from this one here. And as I said, we are going to revisit this. We are going to go to get into details about this. So, but for today, we are done with polynomial functions. So we know when we are given any question on polynomial functions, this is a very simple topic. When given any question on polynomial functions, you can simply tackle it. They are very simple. So it's just a combination of the division of polynomials, also the factor theorem and the remainder theorem, then you're done.